All right, ladies and gentlemen, we are going to talk about our new unit, and we're going to start off with what is called an arithmetic sequence. So before we get going, it's important to understand what a sequence is. To put it simply, it's an ordered list of numbers. Okay? And this ordered list of numbers has special parts to it that we're going to get into more detail in a little bit. But for now, that's all you have to know. Okay? There's two types of sequences. The first one we're going to talk about today is an arithmetic sequence. So an arithmetic sequence is when you have a sequence with a common difference. Okay, we'll talk about what a common difference is in a bit, but that's pretty much the definition of it. So to think about it is if you have an arithmetic sequence, you must have a common difference. And it also works in reverse. If your sequence has a common difference, then it's an arithmetic sequence. Okay? An example of arithmetic sequence is a list of numbers that would look something like this. Okay? Pretty simple how we get from 2 to 4, from 4 to 6, 6 to 8. This is my list of numbers. You should be able to see the pattern. This is an example of arithmetic sequence. Now, let's head into what a common difference is. So a common difference is when, or is the number that is added or subtracted to get to the next number in the sequence. Okay, for example, of the sequence I put up here, I know this is going to be arithmetic because to go from 2 to 4, I have to add or subtract a number. In this case, I have to add 2. To go from 4 to 6, I have to add or subtract the same number, which is 2. 6 to 8, I have to add 2. Therefore, the common difference in this sequence would be 2. So that's basically what a common difference is. What number do I have to add or subtract to get to my next number? And that number that you add or subtract is called the common difference. And the key thing is those numbers that you're adding and subtracting have to be common. For example, they're all positive 2. We're adding 2 every time. Okay? Next thing we have here are some formulas that we're going to talk about and use. So again, here comes the M word. You got to memorize this. This is called the recursive formula. And this one, the explicit formula, has 2 types of formulas. Okay? You got to memorize all 3 of these. So what's the difference between recursive and explicit? The best way to describe it is recursive is a formula that uses a previous number to get the next number in the sequence. Okay, so in other words, in order to get 6, for example, using this example of a sequence up here, in order to get 6, I first would have to know that before 6 was 4. So I would use 4 in this formula. I'll show you how to use it in a bit. I would use 4 to get 6. Without the number before 6, I would not be able to figure out the next number. Or another example is I would need 6 in order to get the next number, which would be 8. Okay? In order to get the next number after 8, I would have to know that this number was 8. Okay? The other thing I want to mention is these numbers in a sequence have a special name. Each number in a sequence is called a term. So this is a term, this is a term, term, term. We'll go in more details on that. So recursive uses a previous number in the sequence in order to figure out the new number or the next number. Explicit, on the other hand, is kind of what the name stands for. Explicit means kind of just straightforward in your face. What's great about the explicit formula is you do not have to know any number in your sequence. It will find any term or number in your sequence. Okay, so again, let's go back to our little example we have up here. If I use the explicit formula and I want to know the fourth term, for example, first term, second term, third, fourth term, all I would have to do is plug in certain information into this, and this formula, the explicit formula, would automatically spit out the number 8 as my fourth term. I would not have to know any of this information before. I would not have to know the previous numbers. If I want to know the 100th term, so imagine this list was 100 terms long, this formula would give it to me. If I wanted to know the 1,000th term, I would use explicit because it would automatically give it to me. If I wanted to use the recursive to find like the 100th term, I would have to know the 99th term, and then the 98th, the 90th. I would have to know all the terms before the 100th if I was using the recursive. Okay? So you'll see how these work in a little bit, but explicit formula is a lot cleaner. You really just plug in the number you want and it will spit out your answer. Okay? The variables up here, A stands for initial term, D, okay, D stands for common difference, and N stands for the number of terms, like the term you want, okay? We're going to get some practice with this, so bear with me as we go through this. All right? Again, as I mentioned earlier, explicit formula has 2 formulas depending on how your arithmetic sequence starts. All right? We'll go into detail when we get into some examples. All right, guys, so let's do some examples, and we are going to write recursive and explicit formulas for these 2 examples. So before we start, we have to understand a few pieces, okay? So if you look at this list of numbers, okay, the list on the bottom, which we call f of n, this is actually the numbers in your sequence. Okay, so this is actually your sequence list here. Notice how we have some blank spots so we can fill in later. The list at the top, this number is the term in your sequence. So let me write that down for you real quick. So this is the term in your sequence, and this here is actually your sequence. Okay, for example, this sequence, negative 4 is the 0 term. Negative 1 is the first term. 2 is the second term. And then 5 would be the third term. So if I said, what is the first term in your sequence? You would go to the first term and say, the first term in my sequence is negative 1. Okay? So we are going to use this terminology to go ahead and write these recursive and explicit formulas. Now let's shoot over here. So again, these are the terms in your sequence. The first term is negative 5, the second term is 0, and so on. I want you to notice the difference between these two examples. Okay? This sequence here has a beginning term or initial term. So notice what your A value says, initial term. Your initial term starts at a 0 term. This sequence over here has an initial term of 1. Okay? This is very important because it's going to signify what formula we use here. Okay? And it'll also determine what number goes right in here in the recursive formula. Okay? So, very important that we figure out what is my sequence, what's the initial term. Is my initial term a 0 or is my initial term a 1? Okay? So, let's do this example first. So, in order to do this, we first have to do that idea. Am I using a 0 term or am I using a 1 term? Okay? So in this example, we're going to use a 0 term. So the first thing we want to determine is, do I have the first term? Am I given the first term? Or am I given the, what we call the 0th term? Okay, so in this first example, we are given the 0th term. All right, which means we would be using, for explicit, we would be using this formula here, the 0th term formula. Okay? For recursive, it slightly changes, and the only thing that changes is this 1 turns into 0. Okay? So I'm going to show you how that works. The next thing we determine is our A value, and our A value stands for our initial term, our first number in the sequence. So do not confuse this for the term number. We actually want the first number in our sequence. This is called initial number in our sequence, our initial term here. Okay? And then the last thing we want for arithmetic is we want to find D, the common difference. All right, so let's go ahead, and if we find all these pieces of information, we simply plug them into the formula and we're done. Okay, so let's start with the recursive formula. Okay, so recursive formula, and before I do that, we find all our parts. So in this sequence, I have the 0th term. Okay, so because of that, in my recursive formula, if you look at the top, it says f of 1. All right, so what this means is f of 1 for this would actually be -1. So I'm looking at the, basically say I'm looking at the first term. But we don't want the first term, we want the 0 term. Okay, so my recursive formula, instead of having the number 1 in here, we have our 0 term. So it's going to be a 0 equal to, and now we want to find our a value. So our a value, if you notice, it's our initial term. So we're looking for our a value here. If we do this correctly, our a value is the first number in our list, even though it's called the 0th term. So -4 is my a value. So we have -4. Okay? The next thing we do is, for the recursive, is f of n. N just stays in there because it's a function notation. Equals, we don't plug in for n yet, f of n minus 1. If you notice, I am just following what I have up here for the formula. Okay? And now, before I put in the d value, we have to find the d value, and the d value stands for common difference. So we have to ask ourselves, how do I get from -4 to the next number? What am I adding or subtracting? Remember, common difference is something that adds or subtracts to get to the next number. So if we go from -4 to -1, I'm actually adding 3. From -1 to +2, we are adding 3. From 2 to 5, adding 3. Okay? So it's pretty straightforward. Our common difference is equal to 3. So that means it's a +3. I plugged that in for D. Okay? Guys, this entire 2 formulas is our common difference. I'm sorry, our recursive rule formula. Now, let's go ahead and do the explicit rule formula. And with the explicit, it's the same idea, but now we're using one of these formulas. So again, kind of go through these, answer these questions. Am I given the first term or the 0th term? So again, using this, we are given the 0th term. So that means I'm using this formula here. So I'm going to write that down. So it's f of n equal to, now instead of a, what's my a value here? It's the first guy, which is -4. Okay, and with that, we then look for d value. So my d value, which we already found, is +3. And then the n is just n. Okay, we have just found the explicit formula. Let's go ahead and try the next guy. Okay, let's do recursive and then explicit. All right, so we actually have a first term now. So notice it's not a 0 term, it's a first term. So that means when I do recursive, it's going to be, instead of f with the 0 here, like I did here, it's not f0, it's going to be f1. Okay? So f1 equal to, and then I have to find my a value. So your a value is just the first number on that list, -5. Okay? And then we move on. We have, our formula says f of n equals to f of n minus 1. And then I want to find my d value. What am I adding or subtracting to get to the next number? So let's figure that out. Negative 5 to get to 0, I'm actually adding 5. 0 to get to 5, I'm adding 5. 5 to get to 10, I'm adding 5. So my D value is actually 5, and it's positive 5. We are done with the recursive formula. Let's go ahead and do explicit. So the explicit formula now is, since we have a first term, see the 1, I'm going to use this formula here because I'm given the first term. So f of n equals, now I want my D value. So my D value is going to be 5. And then it's going to be n minus 1. And then we're going to put our A value, which is negative 5, so minus 5. Okay. All right, and this is how you write recursive and explicit rules for arithmetic sequences. Very, very important that we have a full understanding of, do I have a 0th term like in this example, or do I have a first term in this example?